Hello, everybody. Welcome to the penultimate class or the second to last class. I can't believe that the school year is almost over, that I won't have to look at my computer anymore, and that you guys are almost sophomores. Wow. Um, so last week we were talking about how carbon and temperatures in the last several thousand years have kind of gone in cycles and how that's totally natural. And then at the end, we started talking about how that amount of carbon in the atmosphere has increased dramatically over the last just 50 years or so, and how that is definitely not normal. So today we're going to start talking about why we have so much more carbon in the air now. And we know that it's because we are releasing fossil fuels. That's kind of, climate change 101. But we're going to talk about the carbon cycle, which is something that honestly for a long time really confused me. I didn't really understand the carbon cycle and the nitrogen cycle and stuff like that. So hopefully I can put it in a way that will make sense to you. Well, I'm cutting myself off and I changed my outfit. But today we're basically going to be talking about the carbon cycle and how that all plays into climate change. Enough chatting, let's just get to it. So, today we're talking about the carbon cycle and we're specifically talking about different sinks and sources. So, sinks of carbon and sources of carbon. So, the first thing that's essential to get across to you is that the carbon cycle is just another cycle. It's a natural cycle that happens here on Earth, just like the water cycle or the rock cycle. Hopefully, you are starting to make some connections that everything on Earth is related and moves through these different cycles. So, the carbon on our planet is no different, it moves through a cycle. And just like the water cycle, we're not getting any new carbon, right? So the carbon that's in our atmosphere right now, it's not new carbon, it's just coming from somewhere else. So we're going to talk about that today. So the carbon that's on the planet has been here since the beginning of the planet, and it's basically just moving around to different parts through this cycle. So just like the water cycle, in some places the carbon is stored, and in other places the carbon is moving. So I'm going to show you a picture here in just a second. This is just kind of a general overview of the carbon cycle. So the carbon cycle also interacts with all of the spheres that we've been talking about. So it interacts with the atmosphere, obviously, as carbon dioxide. It interacts with the biosphere. That would be like humans and animals and plants. It interacts with the rock cycle. The carbon can actually go into the rocks. And it interacts with the hydrosphere. The carbon can get into the water. So this carbon cycle really starts to wrap up Earth science here in that it's interacting with all these different spheres. And just like greenhouse gases are good in moderation, so is carbon. We wouldn't be able to live on the planet without this element called carbon. So it's crucial for life. And then one more important thing is that the carbon cycle, because it's a carbon cycle, it's able to keep itself in equilibrium through different negative feedback loops, and the sources will equal the sinks. So we'll get to that in a second. This is a very, very simplified version of the carbon cycle. Know that there's a lot of other aspects going into it, and this is going to be a little tricky because normally I'd want to show you this picture and write on the board at the same time. So I'm going to do the best I can here. But first, I'll give you just like a brief minute to get yourself oriented with this photo. So the carbon dioxide is in our atmosphere. The carbon is going to move into that tree. Then it's going to move into the soil. Then it's going to move into the, factory. And then it's going to go back into the atmosphere. And then there's something going on with a cow down here that's breathing. A human could be there also breathing, releasing carbon dioxide. So now and you can see that there's also this fossil fuels down here at the bottom. So let me now draw this for you. Okay, so we're going to start with an even more simplified version of the carbon cycle. So The carbon is in our atmosphere, we know. And when carbon is in our atmosphere, it is in the form of carbon dioxide. So we have CO2 in our atmosphere, and you can see the carbon right here. So we're going to follow that carbon all the way through this cycle. So then what happens is a tree grows. Lovely tree. And if you've taken biology, or if you remember any of your like 7th grade biology, hopefully you remember that photosynthesis, or trees go through photosynthesis. They take in carbon dioxide and they take in sunlight, and they're able to make their own sugars. The important part is that the formula for that sugar is actually C6H12O6. That means sugar. Okay? So the plant is able to take in the carbon dioxide, take in the sunlight, and make this sugar. And that's how the trees will end up growing. Here's our carbon right here. It's the same carbon as this. The tree doesn't have carbon dioxide in it. It changed that carbon dioxide into a sugar. Okay, so now we have our sugar right there. So maybe this is an apple tree. Okay, here's our apple. And we know that apples are pretty sweet. Guess what's in them? Lots of sugar. C6H12O6. Okay, yay. So we have this carbon, it's moving through our tree. Here it is in the sugar. Now a human's going to come along and eat this delicious apple. Okay. So we're about to eat it. We're about to put this carbon right into our mouth. So we don't, our bodies will take this sugar and they will break it down. And one of the waste products of using that sugar in order to do anything, move, talk, breathe, is releasing carbon dioxide. So the sugar that's in this apple, C6H12O6, we're going to use the sugar, and then I haven't been including the arrows, so there, carbon goes there, carbon's going into the apple, carbon is going into our mouth. How do we get rid of carbon dioxide that we don't need? We breathe it out. And we breathe it out in the form of carbon dioxide. Okay, so here's the carbon. It's the same carbon. It's just moving around the system. The same thing can happen to a cow. So the grass is doing photosynthesis. The cow, oh man. Yay, there's my cow. They have tails too. That's more, whatever. The grass has the same sugar, C6H12O6. It's this carbon. The cow eats the grass, uses the energy, and the carbon ends up being a waste product, so it breathes it back into the atmosphere. So that's kind of the really easy carbon cycle step. Carbon in the atmosphere ends up in a plant as a sugar, goes into an animal as a sugar, and then is released back into the atmosphere as carbon dioxide. All right, so that is the really simplified version of the carbon cycle, but obviously it isn't that easy. So if we go a slightly different route, not just into the tree, into the human, and back into the atmosphere, we're going to start talking about how fossil fuels are created. So there's carbon dioxide in our atmosphere, and with the carbon dioxide and the sunlight, our tree is going to grow. But eventually that tree is going to die, along with any ferns or anything that's living out there. When it dies, it's going to fall on the ground. So I'm just going to, instead of drawing live trees, I'm going to draw dead trees and ferns. So they're dying, they're falling on the ground. Okay. So one thing that could happen to all these dead plants is, and what's pretty common, is that all of the carbon that's in here, remember all of these have sugar in them. Okay. What happens around here in Vermont is that when all these plants die in the fall time and all the leaves fall off, things start to decompose the leaves and they will release carbon, this same carbon, carbon dioxide, back into our atmosphere. That's why on the Keeling curve, the winter and then very beginning of spring is really high because they've decomposed these all winter long and carbon dioxide is rising back into the atmosphere. Okay. But that doesn't have to happen. Maybe instead of these falling in onto the ground in a forest, they may fall into a swamp underneath water. And here they can't really decompose and they can't have this carbon going back into the atmosphere. And then maybe a rock slide happens and they get buried. And over millions and millions of years, for whatever reason, there's rock slides, there's swamps, more trees fall on them. And all of this carbon that used to be in the atmosphere, then it wasn't a sugar in the tree, and now it's still in the tree, but it's way down here underneath layers and layers of rock. Well, what happens under layers and layers of rock is that these things, they don't become trees anymore, they start to change. This is how fossil fuels are made. So fossil fuels are basically just old dead plants that get squished, and all of the carbon that was in the tree that was growing is now underground in what is coal. So this all becomes coal. So coal has tons and tons and tons of carbon in it that is stored up carbon from trees that were once living that took in the carbon dioxide. So then what happens is we come along millions of years later in the dark ages when everything is black, trees, and here's our factory. And we go in and we drill down and we get this coal and we bring it up to the surface. We bring it to our factory and we burn it. And this carbon that used to be down here is now here, and it's burned and released and brought up into our atmosphere. Okay. So fossil fuels are basically just old dead plants and trees that have been stored underground. All their carbon is under there, and we bring it up and we burn it and we release it into the atmosphere. Don't worry if you're a little confused right now. We're going to keep talking about this. Hopefully now when you look at this picture, it makes a little bit more sense. Pretty much the main idea is that it is the same carbon that is moving throughout these different spheres and throughout the planet. And in some places, it is stored for a long time, like in fossil fuels, and in other cases, it is released back into our atmosphere. And that starts our cycle. So the next thing we need to understand about the carbon cycle are places where the carbon is coming from and places where the carbon ends up getting stored. So these things are called sources and sinks. So first I'm going to talk about the carbon cycle naturally, without any human interaction. How would this carbon be moving around the planet? So some places where we get carbon from and where carbon is released is through breathing. So humans, animals, anything that breathes will release carbon dioxide into our atmosphere. Forest fires, which are natural events, some of them end up not being, but because humans start them, and that's a wildfire. But forest fires are natural events, and you can imagine that if you had a tree and it had all of those sugars inside of it, all of that carbon, if it burned, you would be releasing that carbon into the atmosphere. So forest fires are another natural source of carbon. Volcanoes, so we can start bringing in the geosphere. And then places where carbon is stored for a long time is called a sink. So, some of the major natural sinks are oceans, and there are different parts of the ocean that hold carbon, but you can have the surface ocean, you can have um, different animals can store carbon in the ocean, and then you have what's called the deep ocean, which is quite literally the deep ocean that can hold carbon. Our atmosphere holds carbon, soil and rocks can hold it, plants and especially huge, immense forests like the Amazon rainforest, right along the equator there, those are storing all of that carbon. And then fossil fuels or ancient forests and plants are storing that carbon underground. Let me show you a little picture of that. So, carbon sinks are a really important part of the carbon cycle because if we didn't have them, all of the carbon would just be in the atmosphere, and that would be an issue. So, obviously, we have some carbon in our atmosphere, but in places with huge forests, we have plants that are able to take in that carbon dioxide. So, we have trees and ferns, they're so beautiful. And these things are able to store tons of carbon in the form of sugar. So they're able to take in this carbon dioxide and store it inside of them. So we have tons of carbon over here. If these forests were to go away, this carbon has to go somewhere. It doesn't just disappear, it's a cycle. So it has to go somewhere. So if we take out this forest, it's going to go into our atmosphere. Another really important place where carbon is stored is in our oceans. So obviously the atmosphere and the ocean are touching right at that point. And guess what? They want to be in homeostasis. They want to be in equilibrium. They want to have the same amount of carbon dioxide in the air as they do in the water. And right now we have a lot more carbon dioxide in our air. So, we have carbon dioxide that's able to dissolve right into the ocean. And it will keep doing that until it's balanced out. And over time, this carbon dioxide will work its way down into the deep ocean. And if it makes its way into the deep ocean, that's like really, really far down. That's going to get stored for a long time. And along the way, other creatures may use it, other animal life, or it may be used to make some different types of rocks. But a lot of that carbon dioxide is actually just dissolved right into the water. Carbon can also be stored in rocks, like I talked about over here. It can be stored in the soil, like when these plants die, all of their decomposition might not be released. So some of the carbon that was in them might end up in the soil. And then the last huge sink of carbon is a fossil fuel. So if this whole thing ends up dying, we're going to move the surface of the earth now. If this whole thing ends up dying and getting covered and squished and squished and squished over millions of years, all of this carbon is going to become coal or oil or natural gas. So this is going to create a fossil fuel right here. So we've been talking about fossil fuels. I've been throwing it out. You've heard the word before, but what exactly are fossil fuels? So there are three types you've probably heard of before: coal, oil, and natural gas. You use all of them all the time. So coal is something that people are usually like, oh, we don't use coal anymore. That's back in the old days with the steam engine trains throwing the coal in. But that's not true. Most electricity comes from coal. I know some of you might have solar, which is awesome. And as a state, we're trying to move more towards solar and towards wind in general. But for the most part, most electricity is coming from coal. Oil is basically what we live off of. Can't survive in these days without oil. So, some of the more common things that you think of with oil include like heat. If you heat your home with oil, it's coming from um, fossil fuels. Gas is a part of oil. Plastic, all plastic comes from oil. Tires come from oil. Synthetic fibers. That's a lot of your clothes are made out of oil if they're not made out of cotton or other natural fabrics. Let's see what else is made out of. Some gum has oil in it. Lots of cosmetics like makeup do, shampoos, tons of stuff. I'm going to include a link where you're going to look and see what things in your life are made out of oil. So just standing right here, this marker has oil in it, or petroleum. That's another word. Natural gas is essentially methane, and it forms near oil. And what we use natural gas for mostly is heating or cooking. So propane, which if you have a gas stove, it cooks on propane, or a gas grill, you're burning natural gas, and it is a fossil fuel. So I'm also going to include some links to some interesting and quick National Geographic articles if you want to read more about this stuff. I know what fossil fuels are, coal, oil, and natural gas, and how we use them now, but how are they created? So I've sort of started going over this, but basically before the dinosaurs, so millions and millions of years ago, there was lots of plants and trees and things that grew, and lots of them fell into swamps and they got buried and covered by dirt and water. And over millions and millions of years, the heat and pressure from everything above them were able to turn these dead plants into coal. The same thing happened in oceans to make oil, except instead of being trees and ferns, it was mostly planktons and other little creatures that lived in the water. So these fossil fuels take millions of years to create. So we can't make any more. However many fossil fuels are on the planet right now are going to be the amount that we can use. So there's a finite amount, the opposite of unlimited. There's a finite amount. And that's why they are called non renewable, because we can't get any more. If we use all of the oil and all of the coal, it's gone. And what's really important about these fossil fuels is they are storing, as part of the carbon cycle, they are storing tons and tons of carbon underneath the earth. So it's not out playing in the atmosphere, it's just stored down underground. Remember, we're talking about the carbon cycle. We're talking about how some things are sources and some things are sinks of carbon. And now we understand a little bit more about that last bullet about how fossil fuels end up being natural sinks of carbon. And what's awesome about the carbon cycle is that the sources will equal the sinks. So the same amount that is put out into the atmosphere will end up sinking into somewhere else until they don't. So this is where we bring in the human aspect. So issues start arising in this perfect balance when sinks actually become sources. And that's pretty much due to human activity. So on the left here are some of the major sinks we have. So forests, oceans, and fossil fuels. So if we take a forest and we cut it all down, we do deforestation in order to make room for factories or shopping centers or whatever we are cutting down forests for. We are now taking that carbon, and all of that carbon ends up being released into the atmosphere, and there's no more tree there now to soak up the carbon. So it's a double whammy. It's not soaking in any carbon, and all that carbon that was stored ends up getting released. The oceans are another huge sink of our carbon. And what happens is when we start getting lots and lots of carbon into our water, coral reefs start to bleach. And the carbon actually makes the water more acidic, which means that animals aren't really able to create shells. And they're supposed to be creating their shells out of carbon. So if you put too much carbon in, then they're not able to do that and they're not able to take the carbon out of the water. And these oceans can only store so much carbon. So eventually, these oceans, if they end up with more carbon than the atmosphere, they actually might become sources because they'll be putting carbon into the atmosphere from the ocean because they want to stay in equilibrium. And then fossil fuels as a sink, this one is obvious. If we are taking something that is supposed to be stored underground, we are going down, digging it up, bringing it to the surface, and then burning it into our atmosphere. That's going to add a lot more carbon into our atmosphere. And it's going to take millions and millions of years to take that carbon out of our atmosphere and create new fossil fuels. Basic idea with climate change and why there is so much more carbon dioxide in our air now than there has been in the past is because humans are essentially interfering with this natural cycle where the sources and the sinks equal each other out. And we are changing that balance. We are changing that equilibrium. So we're taking something that should be a sink and turning it into a source. So we're taking carbon that's been stored away for thousands of years, kind of like the clothes that are in the back of your closet or the bottom of your drawer. And now we're bringing those into circulation and we're starting to cycle those through the system. And that's going to start messing things up. And we can't make those fossil fuels as quickly as we are burning them because in order to make fossil fuels, it's going to take thousands of years and the most perfect conditions in order to create coal and oil. And basically, we're just adding more carbon into the system than the system can naturally maintain itself and keep itself in equilibrium. So, what happens is we get too much carbon that's ending up in our sinks and it's starting to change our composition. So, we're getting too much stored in our atmosphere, we're getting too much stored in our oceans. And because carbon affects every single sphere, by changing how much carbon is in these different spheres, we start impacting every single sphere. And you can imagine that if we're impacting every single sphere, it's going to start creating this snowball effect. It's going to start creating this positive feedback loop that keeps affecting more and more systems and not in a positive or good way. All right, so that is your general overview into the carbon cycle. If we were in school, we probably would have spent like 2 weeks learning about it, but we've condensed it into 20 minutes. So I hope that you understand it a little bit. It's something that you will talk about or have probably talked about in biology as well. So you'll get another dose of this information. Um, so you are going to do a short assignment, which is posted in Google Classroom. And that's about it. All right. See you guys later.